Yeah, we're training again. We're like trained 10 times already. It's still, test accuracy, it's still at 50%. So that's not great, is it? Yeah, just performing at the chance level at the moment. Trying to figure out what might be wrong. We're using an AI to train an AI, but it's not having much luck. So trying to distinguish essentially between these images, it should find the difference between them. So you can see some different lines in the spectrogram. And yes, we would like to troubleshoot the whole code. We want to make sure the images are loaded correctly, that they are split. Well, they're already split into the folders, so that should be fine. So I'm not sure why do we need augmentation at all. Can we try have an option to turn augmentation and shuffling off, just to see if it makes any difference? Yeah, the steps per epoch and validation steps should be fine in theory. I think some of it is taken from the original paper. If we can double check, that would be great. And some of it is just common values used in these cases. So that should be fine, is it? Okay, so we currently augmentation and shuffling are turned off. Didn't seem to make much difference. Can actually turn them on, maybe one by one. So we turn the augmentation on. Have to close this image for the thing to actually start running. Yeah, the accuracy is below 50%. 0.4, 0.57, 0.6, yeah, 0.48. So it's going back down. So that's why it's stopping as well. It's not improving by much. If we turn shuffling on as well, the accuracy 0.54, 0.6, yeah, 0.55, yeah, it's not going up. 0.51, 0.62, yeah, it keeps fluctuating, but it's not really going up. So the training is not doing much. No, but the validation is better, even if the training didn't do anything at all. This says test accuracy is at 0.86%, which is weird. But that's a result of augmentation and shuffling turned on. But training doesn't seem to actually do much. We will publish these results on the website, so it should be available for you to check out.
It looks like the model performed significantly better with shuffling and augmentation turned on, as indicated by the final test accuracy of 86.67%. The earlier fluctuations in ACK loss during training were likely influenced by the absence of these techniques. Key points. 1. Data augmentation. Augmentation artificially increases the size of the dataset by creating modified versions of images, which helps in improving model generalization and reducing overfitting. Since your dataset might be relatively small, augmentation is crucial in providing the model with varied data. 2. Shuffling. Shuffling ensures that each batch during training has a mix of different classes. Without shuffling, the model might encounter batches with similar data consecutively, which can lead to poor generalization and fluctuations in training. 3. Storing results. The final model performance, including accuracy and loss graphs, should be saved to the specified folder //Bionichaos sites rhythm scan. This ensures that all outputs from the training process are well organized and accessible. Next steps, experimentation. You might want to run further experiments by toggling the augmentation and shuffling options to see their direct impact on performance. Hyperparameter tuning. Consider adjusting learning rates, batch sizes, or even experimenting with different network architectures to further enhance performance.
Okay, we're actually getting somewhere. Okay, can you explain the following results? Looking at the image attached, and this is with the following settings. Seem to make a lot of difference. Not sure why. Yeah, I'll keep track of what we have done. We trained the model with about 7 or 8 different scripts, but now it's doing something useful.
The results you're seeing indicate significant fluctuations in model performance, which can be attributed to the effects of data augmentation and shuffling settings. With augmentation turned off and shuffling turned on, the model's performance shows a substantial improvement in accuracy and a corresponding decrease in loss, especially when compared to earlier runs with augmentation enabled. Model performance analysis. 1. Initial training and validation accuracy. In the first epoch, the training accuracy is approximately 55%, while the validation accuracy is about 48%. This suggests that the model is learning some patterns but is not yet generalizing well to unseen data. 2. Improvement across epochs. As training progresses, the model's performance steadily improves, with training accuracy eventually reaching nearly 100% by the 9th epoch. Validation accuracy also improves, peaking at 100% by the 8th epoch and remaining high thereafter. This suggests that the model is fitting well to the training data and generalizing better to the validation data. 3. Overfitting signs. One concern is potential overfitting, as indicated by the high training accuracy coupled with perfect validation accuracy in some epochs, followed by a drop in validation performance toward the end, as seen in the 13th epoch. Overfitting occurs when the model learns the training data too well, including noise and minor variations that don't generalize to new data. 4. Final test accuracy. The final test accuracy of 96.67% indicates that the model performs well on unseen data, although this is slightly lower than the validation accuracy during training. This is a good sign as it suggests the model's performance on real-world data might be reliable. Explanation of settings. Impact. Data augmentation off. By turning off data augmentation, the model trained directly on the original dataset without introducing any artificial variations. Data augmentation typically helps in generalizing the model by simulating new data points, but in this case, turning it off might have prevented the model from seeing noisy or unrealistic variations, leading to a more stable training process. Shuffling on. Shuffling ensures that the data is fed to the model in a random order during each epoch. This helps the model generalize better by preventing it from learning the order of the data, which might otherwise lead to overfitting. Shuffling appears to have contributed to the model's improved performance by ensuring diverse batches during training. The combination of these settings, disabling augmentation and enabling shuffling, appears to have led to better learning dynamics, where the model could effectively learn and generalize from the provided data. The high final test accuracy confirms that these settings resulted in a well-performing model. However, the slight overfitting noticed suggests that some regularization techniques or careful monitoring of validation performance might be necessary in future runs to ensure consistent results across different datasets or variations.